we're going to finish. We finished the one on the left. Is that correct?
Yeah.
Not the range? It was negative infinity to infinity, wasn't it? Because it had that middle piece. Okay. We didn't graph it?
I don't know if we graphed it.
I think we did. Okay, the second one, right? Yes, that's what I thought. Okay, the second one, and you'll have to remind me of some of the answers. Pretty much the only answer we don't have is the range in the graph. Is that right?
Right.
Okay, so let's do it. It had a y-intercept of?
0, 1, half.
Okay. It had a hole at
3.
Okay, that's the best I can do. Close enough. It had a vertical asymptote at -2. Okay. And horizontal asymptote at 0, right?
Yep.
Well, you can probably tell the right-hand piece of the graph is going to look like this. I have not gotten very good at the graphing on this thing yet. But to get the left-hand side of that graph, I need to pick a point. Either it's going up like this or going down like that. If you remember multiplicity, you probably know that this is going down, but hey, if you don't, we'll just pick a point. -3, plug in -3 into the function. I would pick the reduced form. Didn't we reduce it to 1 over x plus 2?
Yeah.
If I plug in -3, don't I get -1? So it looks like. Doesn't that also just look like 1 over x shifted left 2 units?
Yeah.
Except with a hole in it. So that's pretty handy. Let's talk about the range, and I'm gonna get even more technical than you probably learned in Algebra 2. You'll probably never have to be this technical, but we'll, just for fun. So let's talk about the range. -infinity up to 0. The whole is at a y value of a fifth, right? Oh. So Miss Lowe probably didn't make you be that technical. Oh, good. She's good.
I did it on there.
She did make you?
I did it on this.
And if there wasn't,
We had to, like,
would you just change -0 to 0?
So that one that's a particularly hard range. You would miss that on the calculator, wouldn't you?
Yeah.
You would never see that 1/5 break in the calculator. It's technically there. Okay, any questions about that one? Okay. We did it with -infinity to infinity because of that middle piece. Do you see that? So that takes care of all of the y values just because of that middle piece. I went ahead and factored just to save you time. You better be able to factor that. But domain. -infinity to -3, -3 to 3, 3 to infinity. Do it. Okay. We definitely have to do range last. We can't do it yet. Vertical asymptotes. X equals -3. Holes.
3.
Good. And how would I find the y value of that? Plug it in. 5/6. Does everyone agree? X-intercept. How do you know? It's top 0, which makes the whole thing 0. Y-intercept. Okay, this feels very different than it felt yesterday, doesn't it? This took us forever to walk through this yesterday, and we're going through very quickly, so good job. Horizontal or oblique asymptotes. Y equals 1. Now, I want to walk you through the why on that. Remember, I told you every time we came to a new type, I'd walk you through the why. Remember, as x gets really, really big, that's what affects horizontal asymptotes, right? If x gets really, really big, the leading two powers take over. So x squared over x squared takes over. What is x squared over x squared?
1.
1. There's your horizontal asymptote. Does that make sense? The wording is it's the ratio of the leading coefficients. But it's as x gets really, really big, when you square really big numbers, that affects your numbers a lot more than subtracting 6. It's kind of like Bill Gates and $1, right? He just doesn't care. So we just don't care about those little dollars back there. Does that make sense?
How'd you get the wires?
Well, it's the ratio, like, it's, this one is x squared over x squared, so it's 1. If it were 5x squared over x squared, then it would be 5. Mm-hmm. Yep. If the bottom is bigger, then the bottom's getting big. Right. It's none because it doesn't level off to a single number. It's approaching either infinity or negative infinity.
So big carries more.
If that works for you, yes.
Really small can't carry big. Because it's like on top. So like x to the third is not x to the second.
X to the third over x squared has no horizontal asymptote. There's no horizontal asymptote. Okay, graph. Plot the information. Y equals 1, x equals -3. Um, 0 2/3, that is below that horizontal asymptote. Negative to 0. Would you agree that those 2 points are probably enough for me to graph the right-hand side? And then the 3/5 or 3 5/6 is a whole. I'm going to approach that horizontal asymptote, and I'm going to approach that vertical asymptote. Then to get the other side, what am I going to do? Plug in a number to the left, like -4. If I plug in -4, I would get -2 on the top. On the bottom, I would get -1, which is +2. Am I going too fast? I am going fast, I know. It's am I going too fast is the question. Okay, range. Negative infinity up to that whole. That whole to 1. Right? And then 1 to infinity. You're right on the domain. You would have negative infinity to -3, -3 to 3, 3 to infinity. Questions?
I have a horizontal asymptote, but it does cross it. What's the range then?
It depends on the picture. So we'll always want to look at the picture. So if it crossed, like on this one, if it crossed, like say somewhere in the middle it crossed, then that would have covered up that one problem there. So every time we do range, we're going to want a picture. Okay, slant asymptotes is really why I'm doing this one. We'll do the whole thing. The top does not factor. Do we agree with that? It does not factor. Did you come to something like that on your homework? It's okay. It won't kill you. It doesn't factor. Domain, negative infinity to 1, 1 to infinity. Vertical asymptotes. If the top does not factor and the bottom does factor, do they have any common factors?
No.
No, because the top doesn't factor, right? No holes. X-intercepts. I can find those. This one I can do by hand because it's negative 3x squared plus 2, but I do want to talk to you real quick about how you can do those in the calculator. Of course, you can use your graphing screen, but I do want to take this opportunity to introduce you to Polysmalt.
What?
It is a program in your calculator, and it will do things that aren't just quadratic. It'll solve any polynomial equation for you. So if you come to one on the polynomial section that you can't do by hand, you could use it. It's great. It's called Polysmalt 2 in my calculator. If it's called something else in your calculator, if you have any version of Polysmalt, use it. If you don't have it in your calculator, it'll take me 2 seconds to download. Just catch me after class and I'll download it. Apps. Click Apps. It is built into the new calculators, but if you don't have it, like I said, the transfer takes me seconds. If you don't have it, look on with someone who does or watch my screen. Okay, we ready? Everyone watching?
Get to it from there.
So if you don't have it, just bring me your calculator after class. I'll give it to you. Number 3 is Polysmalt. And the first thing I'm going to choose is Polynomial Root Finder. You will notice that the smalt part of this is a simultaneous equation solver. That would be like a system of equations. You have 3 equations, 3 unknowns. You could click systems of equations and you could solve a system in your calculator using Polysmalt. So that's the other part. I'm not going to show you that today, but you're welcome to explore that. But I'm going to pick number 1, which is Polynomial Root Finder. The order is the same as the degree. So on this one, it's a degree 2. This one's silly to solve in my calculator. I'm just going to tell you, it's much faster by hand. But for, what was it, number 5 or something on your homework? This could be nice. The power is the order. So this is a degree 2. And then the rest of that stuff for this particular problem doesn't matter. You can read through it and see if you care about what the rest of that stuff says. Go to graph, which you'll notice says next. And you type in the coefficients. What was it? Negative 3, 0, and 2 on this one? Negative 3, 0, 2. Why 0? There's not an X term. So for like number 5 on your homework, you type all 3 of the coefficients. It does have to be equal to 0 for this to work. It does have to be equal to 0 in standard form. And then click solve. And it'll tell you the answers. It's great fun. This one you could have done by hand. It's the square root of 3 or 2 over 3. Is 2 over 3 or 3 over 2? I don't know. I'd have to look. So you could do this one by hand so much faster than you could do this, but I just wanted to take this opportunity to show you cool things in your calculator. Okay, any questions about that? Then you go to y equals, which is main, and exit to get out of it. Quit Polysmalt. And you're back to your home screen. Cool program. It is built in. It is one that does not generally delete even when your calculator is cleared. It's especially the new calculators. It's built into their hardware. So it's not like a program. It's a built-in part of the software. So it's something. As long as you have a TI-84, you'll have that program. Okay, so the x-intercepts, just because you could have done this one by hand, I'm going to go ahead and write those as plus or minus the square root of 2/3. But we learned that that was negative 0.8 something and positive 0.8 something. Y-intercept, negative 2. What kind of asymptote? Well, the numerator is bigger than the denominator, so there is no horizontal asymptote, right?
How did you get the y-intercept so fast?
Good question. How did I get the y-intercept so fast? I am plugging 0 in for x. So everything that has an x goes away, and you just are left with constants. Good question. How did I do it so fast? Yeah, because 0 plus 2 over 0 minus 1.
How'd you do
No,
that?
why? You're so speedy.
Calculator, or set the top equal to 0. And I said, even though I showed you in the calculator, this one could have been done by hand because there was no middle term.
How'd you do a horizontal function?
The top is bigger than the bottom. So as x gets really, really big, this function also gets really, really big, or really, really small, either toward infinity or negative infinity, which means there's no, it doesn't level off to a number. There could be a slant asymptote, and for slant asymptotes, they don't come up in calculus that often. The reason I left them in the notes is because polynomial long division does come up sometimes, so I just wanted to practice polynomial long division, really. So it was a way to do it. Slant asymptotes happen in a very particular case, and that's when the degree of the numerator is exactly 1 more than the degree of the denominator. Okay? So the degree of the numerator is 2, the degree of the denominator is 1. And the reason this works is when you divide this out, it's going to divide into be a linear equation, right? And so as x gets really, really big, the y value is going to approach that linear equation. That's what a slant asymptote is, whatever that linear equation is. Does that make sense? So just for funsies. This particular problem could be done with synthetic, and anytime you come to one that can, you're welcome to use synthetic. I'm going to show you long division because, as you know, some can't be done with synthetic. Does anyone remember when you can and when you can't use synthetic? Good. Your divisor has to be x plus or minus a number to use synthetic. If your divisor is not x plus or minus a number, say it's x squared or it's 3x minus 2, you could make synthetic work with 3x minus 2, but you'd have to do some clever factoring to make it something else. But so those, things like that's where I just pick up long division. You ask yourself, x times what gives you negative 3? X squared, negative 3x. Do we agree? So really all I'm asking is x times what gives me this first term. Then I'm going to multiply the negative 3x down. So I get negative 3x squared plus 3x. I'm going to subtract both pieces. How do you subtract a negative? So I'm going to do 2 marks there. I'm going to change both signs. If you messed up polynomial long division in algebra 2, that's probably where you did it at. Would I be right on that? Maybe. Minus 3x plus 2 is what's left. X goes into negative 3x plus 2, so x times what gives me negative 3x? Negative 3. So I get negative 3x plus 3. Subtract it, which means I change both signs. So I get negative 1. For horizontal, or for slant asymptotes, the remainder actually does not matter. This is the remainder. For other things in Cal 2, the remainder will matter, so it's good for you to know how to do polynomial long division. What we really need to know is this line right here. Just, again, way more information than you would ever need to know. But I could rewrite this. This was done with division, right? So this equation is completely equivalent to negative 3x minus 3 plus negative 1 over x minus 1. That's what we did. We divided. And the remainder is the leftover portion. Oh, again, way more information than you ever need to know. But the why behind this is as x gets really, really big, this piece goes to 0, right? And so as x gets really, really big, it looks like that. Way too much information. The answer is the quotient. Y equals the quotient. Seems like there was something else I was going to tell you. Anyway. So the oblique asymptote is always the quotient. And again, mainly I wanted you to just see those words. I know what I was going to tell you. If the power on top were 2 more than the power on bottom, instead of 1 more, when you divided, would you get a line? You'd get a quadratic, wouldn't you? I bet the ends on those look more quadratic in shape. And if you divided 3 more on top, it probably looked more cubic. If you divided 4 more, it probably looked quartic. On ends. Not in the middle, but on the ends.
So the slant asymptote is funny.
Right, because then when you divide, you get a line. Yes, Nikki.
So if there's not a horizontal asymptote, do you have to do the slight one?
Try it, yeah. But remember, the only case where there is a slant is if the numerator is exactly 1 degree more than the denominator. Okay, so graph that slant asymptote. Can you graph lines? We all hope so. Y-intercept of -3, y equals mx plus b. Slope of -3, so if I go up 3, I'd go left 1. And I'm going to draw that as a dotted line. Mental note, those 2 points are not points on my graph. They are points on my asymptote. Does that make sense? So that is my slant asymptote. I have a vertical asymptote at 1. Is that what I said? This graph's probably going to go way off my grid. You might want to think about that before you start graphing. I didn't, so we'll just have to work with it, but that's okay. Okay, y-intercept is 0, -2. And remember these, let me use a different color. Now that I'm done with asymptotes. The red is the actual graph. Plus or minus 0.8. So I think I know what this piece looks like. Do we agree? Follow that asymptote. I'm not doing a very good job of that. So we've got kind of a sideways U shape. That outside, though, is going to follow that slant asymptote all the way out. What I don't know is how far down this guy is. How could I find out? I kind of have an idea what it looks like. Yeah, pick 3, pick 1, or pick 2, plug something in down there and kind of get an idea of how low this, essentially there's another U shape down here, and I don't know how low it is. Now let's talk about range. Calculator question. Why?
Because you divide the exact points.
I don't know how high up this U comes, and I don't know how low this U comes. So to find that, I'm going to have to pick my calculator up and do a maximum on this bottom U and a minimum on the top U. Are y'all okay if I don't do that? Okay, just for time's sake. But that's how you would do the range. Calculator question, if there's a gap and you have to find a max or min. We will learn how to find maxes and mins by hand in calculus, but we are not there yet. Okay, that's another slant asymptote. Can I skip it? That one, what kind of asymptotes here? What kind of horizontal or slant?
Horizontal.
Horizontal what?
0.
Y equals 0, how do you know?
It's bigger.
Bottom, the numerator is smaller than the denominator. What kind is this one?
0.
Horizontal, y equals 2. How do you know it's y equals 2? Same degree, and I'm going to divide. Everyone see how that works? What about this one?
It's going to be 2.
Horizontal 2. That one is factorable on top, so it's not one you have to use a calculator.
So if they're the same, you divide.
You divide the 2 leading terms, yeah.
And if it's bigger on the bottom, then 0.
0.
0.
Okay, there's no horizontal. Everyone agree? Is there an oblique? Yes, because the degree on top is exactly one more than the degree on the bottom, right? So you have to do polynomial long division. Okay, let's do a polynomial problem. And that'll end our... Does that get you everything? By the way, tomorrow we're going to quiz over rational functions. So a little quiz like the logarithm quiz over the rational stuff. Kind of like a homework quiz. Kind of like a little homework quiz. But you know it's coming. Solving equations and inequalities.
So as long as I can do this homework paper,
Yeah. But what that does mean, essentially I'm doing the same thing I did on logarithms. I'm making you stop and say you need to memorize how to find vertical asymptotes and horizontal asymptotes and... Yes, just rational. Yeah. And there will probably be one problem, maybe two, right? Because it takes too long to do very many more. Kind of like a logarithm quiz, it won't take you real long. Just have a quick quiz. Polynomial function. What's the domain of every single polynomial?
negative is negative, positive is
Why?
negative.
There's no denominators. There's no logarithms. There's no square roots. It's beautiful. I agree. Your range. I'll skip it for now. Zeros. You gonna do those by hand?
Yes.
Yeah. Good luck with that. So, we could, or we could do this one. But if I can't do it by hand, now of course, as you know, you could go to your graphing screen and you could do the zeros button 5 times. Have fun, right? Or, I learned a cool trick today. Poly small. Oh, you did. I already knew that. Yes. What's the order of this particular polynomial?
What's the highest degree?
It is the highest degree, which is 5. So if you don't mind, I'm going to leave this up. I'm going to put my screen down so I can type this in. So I'm going to go over to 5, and I'm going to push next. And I'm going to type -2 in for my A5, 5, and -6, 8, -2, and 2. Be careful if any are skipped. Make sure you put 0. Does everyone know what I mean by that?
So if it's like 2x to the 4th power minus 9x squared, it just be 0.
Right, 0 for all the ones that aren't there.
No, not. Can you just again?
Oh, say that again. 2x.
2x to the 4th minus 5x squared.
Yes, because you can factor out an x squared and set each piece equal to 0. So yes, you could do that by hand. Okay, and I'm going to click graph, which is the solve button. It's taking a while. Why do you think it's taking a while? It had to find 5 zeros. Think about if you went to your graph screen and did that. It takes a while. It didn't take that long, though. And there they are. There's your 5 zeros. Okay. Questions, comments, thoughts? Awesome, right? Okay, so that's how you find the zeros. I'm not going to write those down because... But does everyone see how that works? STO is store. You can store those values if you wanted to. Yes.
So, mine says like
Uh-oh. Good question. I need to pay attention to that. I've got too many decimal places showing. Oh, some of those are imaginary. Time out. I'm glad you caught that. I'm going to go back to main. And I'm going to change mine to...
real.
Yeah, float 3 would be great.
Probably real.
Yeah, or you could just change it to real. That would work. Real would probably be the best. Because for calculus, do I care about imaginary? Uh-oh, it's not letting me go over to real. Are there no real ones?
kind of went to 5 it crossed out real.
Whenever you went to 5, it won't just do real. Interesting. Let's see.
Guess the table went on.
Guess so.
Pascal.
Okay, I'll just go look at them. When you do float 3, sorry, how many of them are real? Or you could, float 3. Let's see. I'm glad you caught that, James. You're paying attention. There's only one real one, isn't there? So this would not have taken me very long in the graphing screen. There's only one that's real, 1.948. And why did they suggest float 3? Why was that a good choice?
That's how many we have to go.
That's how many you have to go to. So, x is approximately 1.948. Okay, y-intercept. What's the y-intercept? Perfect. How do you know? Put 0 in for x, it's going to be the constant. Relative extrema. What is that?
What?
Anyone know?
4.
Anyone
It's
know what that
minus
means?
4.
It's maxes and mins. Do we know how to find maxes and mins in the calculator? Yes, definitely calculator. Okay, so you type the equation in y1. Did it ask that on your homework, Extrema?
No.
So you didn't even have to do those. It's good for you to know.
Range.
So you have to do it for range on some of them. That's probably why I put it in the notes. I don't remember.
There's a graph.
I will show you. Okay. This is my graph, and graphing you can easily see why I just wanted to show you polysmalt for today, but you can easily see why there's 1, 0. Only crosses the x-axis one time. There is a relative minimum and a relative maximum on this. Does everyone see what I mean by that? Those are collectively called relative extrema. It's just the plural of extreme values, which extreme would be maxes and stuff. Relative, does everyone know what relative means? Versus absolute. Do we know that? Okay, let's talk about that really quick. Absolute extrema would be the actual highest point on the graph. Is there a highest point on this graph? No, so that's what absolute extrema is. Relative extrema is in a little area on the graph. It's bigger than anyone else in the area. Like, for example, there is a richest guy in Greenwood. I don't know who he is, but there is one, right? Is he the richest guy in the world? No. He is, relatively speaking, a maximum, right? Relatively speaking, or locally speaking, and sometimes they are called local maximums. Locally speaking, he's the richest guy in Greenwood. But globally, that maximum would be different. Now, is the global maximum also a local maximum? Yeah. Somewhere. Right? Does that make sense? So that's way more information than you need, but more alpha stuff. Okay, so second trace minimum, I'm only going to do one of these, if that's okay with you. Left of the minimum, push enter, and then left, and then right of the minimum and push enter. Don't go too far because it's going to give you the smallest point in the interval you choose. So if you go down too far, it would give you the lowest point. So 0.145, 1.862. So that's the relative minimum. And you can do the relative maximum the exact same way. Absolute extrema, which answers, I kind of answered that. What is the absolute extrema? There are none on this graph. Why not? It goes up forever and down forever. Do y'all know how to do intervals of increasing and decreasing? Okay, how do we do that? We always use x values when you're telling me where something happens. Would we agree with that? So this graph is decreasing from negative infinity to 0.145. Why? It's going down, right? Then it's increasing from 0.145 to wherever that maximum is. X values. Always use x values. And then it's decreasing from that maximum to infinity. Does that make sense? End behavior. This should be a non-calculator discussion. End behavior can be done without a calculator because our Bill Gates principle. As x gets really, really big, that guy wins. What does he look like? He's a fifth power and negative. So let's think of another odd functioned power like x cubed. What does x cubed normally look like? Normally looks like that. What happens if I throw a negative in front of it? Goes the other way. So that's the end behavior.
So how do you
For this, just sketch it. Just do a quick little... To say it, if you really wanted to say it, you would say as x approaches infinity, y approaches negative infinity, and as x approaches negative infinity, y approaches positive infinity. Good question. What is any... I think I might have that. No, I don't. Okay, let's talk about if we have an odd degree and a positive in front. We already did negative odd.
It goes down.
Like that, right? What about positive x to an even? Like a quadratic, right? And what about negative x to an even?
Down.
So if you know the degree and the leading coefficient, you're good to go.
Is there only one thing like approaching negative infinity like something?
Yeah, you 2 ways to say it.
Yeah, I don't know.
We're going to learn a new way to say it in calculus in a couple weeks. For today, if you sketch it, I'm good. Okay, if you have any questions, what do we have, 10 minutes left in here? 5? Okay, work, ask me questions. Tomorrow you have a little quiz over rational functions. And yes, if you